All around the globe, scientists have chased the dream of infinite clean power. But hidden in Germany is a bizarre machine that quietly shook the energy world. It might look like sci-fi, but this twisting steel beast is absolutely real, and it could reshape the future of electricity. Unbelievable? Perhaps. A quiet town's secret. Few expect a technological revolution to emerge in a small German coastal town. Yet, that's exactly what happened in Greifswald. Tucked between serene Baltic waters and winding medieval streets is the Max Planck Institute for Plasma Physics, home to an otherworldly device known as the Wendelstein 7X. At first glance, visitors see a peculiar building, discreetly blending into the local landscape. Inside, however, is a realm of swirling magnetics and superheated plasma. The entire project took nearly 2 decades to assemble. Many locals had no idea they shared a neighborhood with a machine that could someday fuel entire continents. Tourists might pass by, unaware that behind those walls, history is being rewritten. The impossible shape. Push open the doors and you find a steel labyrinth. A reactor shaped more like a twisted pretzel than the neat donut most associate with fusion. This is a stellarator, a design once deemed too complicated for real-world use. Traditional reactors, called tokamaks, rely on symmetrical magnetic fields and an electric current coursing through the plasma. The stellarator, by contrast, generates its complex fields purely through precisely contoured magnets. Each coil is a masterpiece of engineering, individually cast and machined to exacting specifications. Skeptics thought it was impossible to mold steel like this at scale, but Germany insisted on forging ahead. They believed that if they could get it right, the rewards would be immense. A long road to completion. Construction began quietly in the early 2000s. There were challenges, specialized materials, one-of-a-kind manufacturing processes, and endless testing. Engineers worried about tiny errors that could unravel everything. One coil, off by a fraction of a millimeter, might cause magnetic fields to misalign, dooming the entire project. Yet progress never stopped. Teams worked day and night, double-checking every weld, measuring every curve, scanning every seam. Delays arose, budgets stretched, and critics questioned if it was worth it. But deep down, researchers remained steadfast. They saw beyond the complexities to a future free from meltdown risks and toxic waste. Slowly, piece by piece, the Wendelstein 7X began to take shape, defying skeptics at each turn. First switch on. In December 2015, the day of the first plasma arrived. Tension was high. Would this bizarre contraption even start? Scientists gathered in a control room